Hi, welcome back. So, from one meaty topic to a trivial thing that's just going to take no explaining at all. So, no, another meaty topic, which is the Windows Runtime app lifecycle. So, we're going to look at how apps behave and how they get suspended, how they get killed, but more importantly, what you have to do as an app developer in order to handle this kind of thing. So, there's a lot that the framework does for you, but it kind of imposes certain behaviors on your apps that you have to be aware of, and you have to write some code to save state and restore state when it's appropriate. So we're going to start, well, this topic is going to talk about launch, suspend, resume and termination, and saving and restoring state. Nice and sweet, but actually there's a lot to talk about.
Yeah.
So why do we have a life cycle at all? And actually this is true for Windows 8 store apps as well. So battery is the most precious resource we have. In terms of user experience, you know, nobody loves a phone that runs down in no time. And if they think your app is a battery hog, in actual fact, and they can find out now because there's a battery there's a battery saver app which will tell them exactly who the hungry apps are. So if your app is a battery hog, you're going to end up with some bad feedback, and people are going to uninstall your app. So the way the OS helps to conserve the battery is that it makes sure that it'll only run one foreground app at a time. First session tomorrow is about background execution. So you can run code in the background under certain controlled circumstances, but there's no UI with anything that runs in the background. So when we talk about a foreground app, we're talking about an app with UI, and there's only one of them at any one time can have the screen. And if the user switches from one app to another, the ones that have been that are no longer in use, they get suspended. And in periods later on, if the phone is getting short of memory, they might get terminated. So we've got many mechanisms. The framework gives you some mechanisms for helping an app to have this illusion that while it's been suspended, it's been running all the time in the background. But you have to buy into this and work with those mechanisms. This is very similar to the way Windows 8.1 store apps work, but there are a few differences due to just because of the more constrained nature of phone hardware, and also some things that are about backwards compat with older apps. But it is very different from the way the Silverlight app behaves in the Silverlight app lifecycle. So this will be, if you're moving from Silverlight or interested in developing for Windows RT XAML, you will find this a little bit different. Okay, so the first concepts: launch, suspend, and resume. All pretty simple, I'm sure, to most of you. So here we go. The user launches an app. So they tap on a tile, perhaps, and we're going to use the calculator as an example here. They launch the app, and the app is running, and the user interacts with it, and life is good, and the app has full access to the CPU and the memory and everything, and it's a happy little calculator. Now, there is a method in your app.xaml which in all the templates you'll have this already in your app.xaml.cs.vb.cpp, which is the onLaunched method, which this is where you can find out, well, you can run some code of when the app is launching for the first kind, and you can also figure out what kind of activation. So you get this in the args, you get this previous execution state, so you can figure out what happened before this launch. What was what happened to it, the last thing in its life? And you can see you've got these 5 options. Not running at all, so the app's maybe just been installed, never run. It was running, it's been suspended, or it was terminated, or it was closed by user. We'll talk about what each of those mean as we go on. You can also find, why has this been launched? Actually, there's a myriad number of ways an app can be launched. I mean, we showed tapping on a tile there, or you can go to the Programs menu and tap on the listing in the Programs menu, those are just launch ones. But you can actually also have an app launched by file. That means we use app-to-app communication, and somebody has sent you a file, and your app has been registered as a file handler for that particular type of file. We talk about that tomorrow when we talk about, what are we talking about? Well, file and protocol.
File open picker.
Yeah, that's right, and the file and open pickers, and the file and URI associations. So that's a file. Protocol is a URI, similar thing. So somebody's launched a URI and your app has registered to handle that URI. And you can voice commands. You could be launched by Cortana. So that's another way. And there's various others as well. So you get a lot of information on launch about why you started up. Now, what happens when your user navigates away from your app? So they've been using the calculator, and then they hit one of these buttons, or you get a phone call. So if they obviously hit the Windows key, that will take them back to the start screen. That's the classical way of going away from an app. Or back, as we saw when we were looking at the back key handling, that would take you out of the app if you're on the launch page. And then the right-hand button takes you either into the search experience, which is Cortana if you've got it, or Bing Search if you haven't. So what happens when you get suspended? Well, actually, all your code is stopped, suspended where it is. All timers stop running. No more events. It is totally suspended. The system will take a snapshot. It sort of puts you into suspended animation. It'll take a snapshot of your working set, your memory. Effectively, that process is still alive. It's just not running. It's not ticking over or any time. But just at the point it gets suspended, you do have a chance to run some code. And that is in this on suspending on event handler. So again, all of the new project templates will have this already wired in, and it will have some template code in this, which is what you're looking at here. And in on suspending, you want to do whatever you need to do when your app suspends, and we'll talk what it is you need to do in a moment. But actually what it will be is about saving data, for example. You might want to save some data away into persistent storage, into files or into a database or something like that. And if you're doing any async methods in there, you need to use this deferral. This deferral is a nice way of allowing you to do async calls within an event handler, but kind of deferring the continuation of the OS as it's trying to suspend your app. You're kind of saying to it, when you take a deferral, you say, well, okay, I'm just going to do some async methods here, so just hang on there. So when you're finished, you then call deferral.complete, and that signals back to the caller that actually this on suspending processing has completed. So you only have a limited time to do all this, so you need to think about this. Don't defer all your work into this on-suspending event handler. Typically, in a mobile app, you'll save files as you go along. You know, as you leave a page, you might save data and that sort of thing. But you only have a limited amount of time in there. This is the deferral thing. If you're doing any async, you get the deferral there and then call it later on. Okay, so now, what happens when the user comes back to your app? So there's a number of different ways it can be relaunched. So the left-hand one is actually the user could go to the start screen and tap the tile again, which would cause the app to be reactivated. Silverlight app developers will notice one change there. We're getting reactivated, not a new instance launched. The middle one there is where you're on you've gone to another app. Here we've gone to the Microsoft.com website, and then you hit the back key from that website, and that's going to take you back to the previous app, which takes you back to the calculator. And the other one is if the user taps and holds on the back key, you get this task switcher comes up where you get these thumbnails of all the apps that you've been running, and you can swipe across to any of them and tap on them to reactivate it. So then as soon as you restart, your code picks up just where it left off. Just starts running all its code, and your timers start. It comes out of that suspended animation, and away you go. You can run some code on that instance. Actually, not so. You don't so often need to do some stuff on this, but this isn't wired into the template. So if you want to run code on resuming, you need to wire up, add that this.resuming plus equals on resuming into your app constructor, wire up the event handler, and then you will create that event handler and you can put your code in there. Now, just to be careful, debugger both is and isn't your friend in this sort of thing. So by design, so that you can debug all these sort of things, when you actually do one of those things through the phone, which on a real app would normally suspend it, like hitting the Windows button, the key, or or search or something like that, or launching another app, then actually your code will still keep running under the visual control of the Visual Studio debug. It doesn't get suspended. But because you obviously need to test these sort of things, we've actually got this special drop down in the toolbar there which allows you to suspend from Visual Studio. So this will trip a number of people up, especially if you're coming from Silverlight, because in Silverlight, when you move away from the app in all of the ways we saw on the previous slide, then your app will actually get suspended. Not true with Windows Runtime apps. What do you want to do on resuming? Well, you have to think about what's the effect of having this pause in your operation. So you might need to check on any external things that you were checking. You might need to call a web service to check that some status has changed or something while your app was suspended. You might need to think if you've got any time-dependent processing. So many apps, it won't matter. If it's a calculator, it just comes up and it's just the same as it was when you left it. But other apps, if you've got some processing there that is time-dependent, then you need to figure out how long you were suspended and adjust timers and do whatever it is you need to do to compensate for the fact that you've not been running for that period of time. There's plenty of other examples. There's a good link there which you can go and have a read of. Refreshing data from an online source. Check. You might have switched the phone might have gone offline while you're suspended. So if you're a networking app, you might want to change your status when you come back. Sensor data, you might want to go and get some new readings. Networking call, if you've made an HTTP request just before you're suspended, when you come back, actually what will happen is that request will complete with an exception because the call will have been dropped while you were suspended. So you might need to make that call again. The phone could have been changed from portrait to landscape, so you might want to do some of that Visual State Manager stuff or something like that. Or go off and get new data that background tasks might have fetched for you, so or from roaming data, which we're going to talk about in the very next module. Yeah, the app can be closed by the user. In the task switcher, when they tap and hold on the back key, and you get the thumbnails up, they just tap on that thumbnail, it relaunches the app. But if they tap on the X, you can actually close the app. So this is for Android fans. This is for you. So this is there's been a lot of in the first versions of Windows Phone there was no way to close an app, but you don't need to because they're suspended. But anyway, people like to feel in control. We get that. So if you really want to close an app, you can through the task switcher. That is where the close by user status comes from. There's no other way that the back button doesn't close an app. Which, again, with Silverlight, if you do a back button from the home screen, that terminates the app. Not true with Windows Runtime apps. So I've got a little bit of a demo to show all that stuff, which I will show you now. Not that one. Here we go. So, oh my gosh, just sign again. Okay, so this little app, very simple. Let's just run it first. You'll be pleased to see these are very simple apps. Here we go. This is a count. You can see this is just a counter running, and it's just putting the count onto the screen. And if you go away from the app at about 10 seconds, and then we wait for like a few seconds, and then we go back to it. What you would expect is it still said 20. It should still say 10 seconds, but it doesn't. It says 22, and this illustrates that fact that it's still been running in the background while it should have been suspended because we're under the control of Visual Studio. If we stop Visual Studio and then go and run that app, which is called App 1, imaginatively. And we suspend it at 2.2 seconds, and then we wait a few seconds, and then we come back to it. So this is a proper suspend because we run it from the phone. It's going to come back at 2.2 seconds. So that illustrates what we were talking about. And if I go tap and hold, I can close it by user. There we go. It's killed it. Now, what if we want that timer to survive? We want the timer to resume with the timer in the right place. So we want it to handle being suspended like that. And when it resumes, to reset the counter so that we know we can sort that out. we can do that very easily. So that's the version that we've just been running, which didn't have any resume handling on it. But now what I'm going to do is simply hash define this an if-def called add handlers, which is going to add in some other code. So now we've added in this.suspending event handler and on resuming event handler. So now in our on suspending, we set a property, this.suspension time. This.suspension time is just a property on this, go to definition, on this class. There it is at the top, suspension time. And so we're going to save in the state the time. And then in our on resuming, we find out what the current time is, subtract the time we were suspended, and then we can reset our timer, the elapsed milliseconds. So we actually, our data value, which is what is the clock is showing, we add on that elapsed numbers of seconds. And when we resume, it will pick up all right. So let's just run it in there. And I'm going to, there we go, we're going to let it run, and I'm going to go up to Lifecycle events up here. I'm going to, at roughly 5 seconds, I'm going to suspend it. And it's suspended. And then we've gone about another 5 or 10 seconds, and we're going to resume it. And it's picked up where it was. So we've got the right behavior that we expected from this app. Nice and simple, just using on suspending and on resuming. Right, what about termination? What is termination? So that was a suspend, and all the time it was suspended, it was just, the process was still alive, it just was suspended. But the OS can terminate your app. So if the user runs a different app, and at this point, and this is kind of more likely on like your 520 there, which is a low memory device, 512 megs memory device. Whenever we suspend, obviously the device memory is being used to hold the memory of any suspended app. So at some point, we're going to run out of that cache. So there's not going to be enough memory. If we got a number of suspended apps, and it can, you can keep on suspending, and you can have loads of these things. At some point, it's going to need to get some memory back in order to suspend the latest one that you've just decided to suspend. So the OS will terminate an app. One of them, it just blows it away. So it will destroy that saved snapshot of the memory. It closes down that process, and it's gone. And the system figures out which one to end, which one to destroy. It's not necessarily the completely oldest one, but it will be one that allows it to get the memory it needs to save the one that it needs to. You don't get any notification in the app. There's no event that fires when this happens. The app gets removed from the task switcher list, but it's gone. So the implication for this is that actually on suspend, you need to think as a developer, actually, that you don't know that you're just going to be resumed from a suspend state. You could actually get terminated. So if the user returns to a terminated app, so that they tap on the tile and restart the app, again using the calculator, what you need to kind of bear in mind is that as a developer, you want to try and maintain the illusion that the app has never been away. You need to make the user think that it's been suspended, even though actually it's been terminated and it's actually been blown away completely and destroyed. So that means you have to write some code to save some data away. You need to maintain that illusion. So you must make sure that the user doesn't lose any data, and actually that their experience is not spoiled by this as well. So there's a lot of things that go into that in what you need to do. You might need to restore what we call transient session state, and you obviously need to make sure you save page navigation history. So when they come back, if they were on page 3 of a multi-page app, when it comes back from terminated, you want to make sure that it starts back on page 3 in most cases. And in fact, if they half filled in some data into fields on page 3, you probably want to make sure that data is still there and visible to them. So this is where you as the developer really need to get involved with this. What do we mean by transient data and persistent data? So if you think about a telephone list, the list of contacts there with telephone numbers, that is the permanent data, the persistent data of the app. This is what the app saves away into a file or a database, and you run it much later on, or you will get all that data back up. This is the permanent persistent data, and you'll save that, this persistent data, you'll save that away into, and you add a new one. And you're adding a new contact onto this with a mobile phone number and a phone number. You choose some contacts, some details like this. And at some point, that data, as the user goes through it and has hit the save button, is getting saved away into a file in your local folder, into files. And we're going to get onto files in the next session. Stores it away into a persistent file. But if they're halfway through filling in that data, so we're on the third screen there, and they're halfway through entering a phone number, but they haven't hit save yet, that's stuff that is transient. It's just stuff that they're halfway through doing. It's unfinished business. That's your transient state data. And that's what you want to think about saving on a page if you want to put them back to exactly the same state that they were in when they left it, when the app was suspended. So if in the meantime it's terminated and blown away, and then later on you restore from a terminated, you need to restore the values of those fields into those fields when it resumes again. Lot to think about. So another demo to show all that. Oh, here we go. Which is also called Imaginatively App 1. And it's a similar pattern to the other one. So we've got some handlers up there. So first of all, we'll run it. And what do you know? It's a timer again. Now, if you look very closely at the bottom, which might be difficult if you're a remote viewer of this, but it actually says at the bottom, it says app previously. So this is the previous state. It wasn't running. So this is a whole new app. And the app has been running for 13.8 seconds. So I'm now going to suspend and shut down. So this is simulating a termination. So we're going to suspend and actually destroy it. So the app has gone completely. And now the user is going to restart it again. And we were on about, I don't know, 25 seconds or something. And you want it to come back from a terminated state. But it started all over again. So we've not saved the transients. We've not shown saved any of the state of that. Now, and also we see if we look at the bottom there, it says app previous state was terminated. So it was terminated by the OS. Now if I hash define this, we're going to add in some of the right kind of behaviors. So now in the save load state, if it's terminated, we're going to, on launched, we're going to load our state from a file. We get our data value back from a file. And I'm sure you won't be surprised to see that in our on suspending, we're going to do some async work. So we've got our deferral either side of it. And we're going to save our state. So we save the value of the counter away into the local file. And so now when it resumes from terminated, it's going to pick up exactly where it left off. So we can demonstrate that now. So here we go. We're running, and we're going to go up to about, I don't know, be about 5 seconds by the time I've done this. There we go. It's terminated. It's not running. Run it again. And now that logic's kicking in, and it's picked up exactly where we were. So we've now got, by saving that state away into files, we're now surviving termination. Now this is a super trivial example, but it gives you an idea of the issues that you have to grapple with here. Right, now then, well, I kind of touched on a few things there, which is like not only that pages need to save values of controls where the user is kind of half finished entering some data. And I also touched on this idea of having a multi-page app, and the user needs to, if they're on page 3, they need to go back to page 3. This is all state that is lost. So The frame, if you remember, manages pages, and it also keeps a record of the navigation history. I told you that a few sessions ago. So that has the ability to, you can get out of the frame its navigation history. It actually has a property on there which returns to you as a string its navigation history. So you can get stuff out of the frame about its navigation history. You can get your permanent data and save it into files, and you can also save on the page transient data such as half-completed unfinished business. And all of these things are ingredients into bringing your user back from a terminated state into where they need to be. Now, there are two classes that are given to you in the more complex project templates, which aren't in the blank template. The navigation helper, which we've already seen, which has the back key handling, but actually that's only one little part of a bigger story. So the navigation helper works actually with another class called suspension manager, sorry. And these two work together to handle all of those different things I was just talking about. So this is run through how it works. For a clean new launch of the app, the app fires the on-launched event, the frame gets created, we saw all this, and then in your frame in the on-launched method, you need to register that frame with the suspension manager. There's a method you call in the suspension manager to register the frame, and that ties the suspension manager in and allows it to get and set the navigation history on a resume from termination. And it keeps aware of that as the frame is navigating. The suspension manager is responsible on suspension, saving all that data away into permanent storage. Now, as the app navigates to different pages, that navigation helper comes into things as well. We already saw how it helps us with the back key handling, but the other thing it does is it's helping to store a lot of other data. So the frame tracks the navigation history, including the parameters. And actually, this is one interesting thing about those parameters, those objects that you pass in navigation. That has to be serializable, because this is all going to get serialized, and we'll talk about serializers in the next module. It's serializable, so you can turn any in-memory objects into into data that can be saved. And so when you get into a page, the navigation helper calls a method called load state, and in there you can put some logic to load the state back into the page on a resume from termination. And as the page A navigates onto page B, as you leave a page, the navigation helper has a method called save state in the page, which is where you can save that page state. So not only as you're navigating away, but actually the key thing here is when you're being suspended while you're on that page. That is where you're going to save state into that as well. So you save all state necessary to reconstruct the page, as you might get terminated. And you get to another page, and this thing goes on and on. You have a load state, save state methods. And when you go back from page B to page A, again, save state as you leave a page. You go into page A to the navigation helper, and on page A, you load your state again. So all this pattern is going on. And this is also where the page cache mode that we talked about before, these are where the load state and save state is where you can reset the state for a page, regardless of whether it's been cached or not. When you go forward, you save state into page B, and then you load state. You can look here, when you're going forward into a page, you look in the load state, there's a clue whether this is a forward navigation to the page. In that method, in load state, you look at the state dictionary that's passed in. If it's null, you know this is a new forward navigation into that page, so you can reset your controls, even if you've got a cache mode required. If there is a state dictionary, then you can restore it. And finally, as the app suspends, in the suspending event, you will call the suspension manager save async method, and that saves everything. It saves the global state, which is the page navigation history, and also the frame state away into persistent storage. Now, there's one thing about restoring state when you come back in, is that there are circumstances where you might not want to do that. So maybe you've been suspended for a very long time, a couple of weeks since the last time the user used your app. There would be no point in putting them back onto page 3 of the app and exactly where they were with controls half filled in, if they hadn't used it for 3 weeks, they wouldn't remember what they were doing. So in that case, you probably want to do just not restore the state, not get the suspension manager to restore state, and instead start from a new state situation. Okay, so a demo to show all of that. So demo 3. Right, so this one, we've got pictures of some young women, and we want to. You can go into one of them, and you can click or select one, and here we're in on navigated to. On that page, we've navigated to a page where we're going to save some data. So we're looking at the view model for the data for this. We're getting the data. We've navigated in. We get the data for this particular page, and we're going to get the data from our back-end storage, from our model for this, and create a view model and set the page context. So we've got an object that we are tied to. Hang on, I'm going to talk through this. Let's just run this through. We've got an object on, and now we can go in and edit, which is like we can start changing the data for this. And this is where we can start putting in I don't know, a name. And we this is like an example of the transient state. So we are going to I'm going to terminate this, suspend and shut down, and then reload it, relaunch it again. And we're back to the home page, which is not where we wanted to be. We expected to be relaunched back at the where we were halfway through doing that editing operation. So how can we fix that? Well, you won't be surprised to know there's yet another of these amazing hash defines. This allows us to use the suspension manager. So this is how the suspension manager is tied into this sort of thing. So that hash define has added in this bit of code here, where this is all this is part of the plumbing. Suspension manager register frame. We need to register our frame in our onLaunched. Here we go, we're in our onLaunch. This is part of the plumbing that you need to use suspension manager. You register frame, which allows the suspension manager to monitor navigation history and to save it. And then when you are on suspending, you tell the suspension manager to save all the data it's been tracking, which is the navigation history, but also it also actually tracks the state of the page as well. And then on launch, we restore the suspension manager, so that brings all that state back again, puts us back to where we were. Silverlight app developers will be aware that the framework does all this for you, but in Windows Runtime XAML you have to actually write this code. This is all plumbed into the more complex templates that use the suspension manager. Then let's have a look at image page. This is wired up to use the navigation helper. And navigation helper, we have this standard plumbing code here. And in our onNavigated to, we wire that up. We call the navigation helper onNavigated to, and on our page onNavigated from method, we call the navigation helper.onNavigated from. That's the plumbing, if you like, for working with the navigation helper. But then the navigation helper throws up these two. These are navigation helper events that are fired, both on save state. So when we're leaving the page, we can save whether we're currently in a view model is saying we're in an editing state, and also whether the view model has stored if we're halfway through entering some text. So it saves that into the state dictionary for this page. And then when we come back into this page, if we're recovering from a terminated state, then we will go into our page state dictionary and restore that stuff again. So let's run this again with all this in place. And go into here again, let all that run, and edit it. A name, halfway through we're going to terminate it. So it should have gone. It's not gone though. Oh, we're on a breakpoint, sorry. So that's saving the stuff away. There we go. And then we can restart it again. And it's going to come in and load the state again, and the result will be we're back exactly where we were. So I haven't got, unfortunately, time. It's a complex subject, but these are the navigation helper and the suspension manager help you to manage these situations by saving and restoring transient state in load state and save state on the page, and by calling the suspension manager .saveAsync and suspension manager.loadAsync on suspending and on launched respectively, then you'll get the page history back as well, and all this magic will work. So there's a number of other topics that relate to the application lifecycle that we're going to be covering. Notifications, which is tomorrow, session. Oh, it says 10. Actually. Oh, no, that's wrong. It's 14. Switch them around. We changed the agenda. Session 14 is Tiles, Badges, Toast, and Action Center. Sharing files and data is 10. Background working is still 11. That's happening tomorrow. And if you want to know about the application lifecycle in Silverlight apps, then there's an awesome session from the last Jumpstart which takes you through all of that.